good morning or good afternoon, whatever part of the day you happen to be in when you're starting this. Of course, you've just done a bell work problem, which is a Boyle's Law problem, and you also had to make sure the pressures were the same. So hopefully you understand the solution on the back for that one. We also, again, today are going to do a short lesson. This one's really short. Yesterday was only about 21 minutes worth of video. Today, again, is even shorter. We're just going to be looking at questions 15 and 16 today, and we're going to do one additional problem that's not on your outline, but it won't take long to look at this particular gas law today. So if you have your outline, I'm going to have you take out your Chapter 14 outline that you were working on Monday, yesterday, and you'll also need a calculator again today. And we're back to basic algebra, so just real simple little problems today that you're looking at, but you will need a calculator. So pull out yours or head to stations 11 and 12 to grab a calculator. Okay, so question 15 asks about another gas law. And this gas law is the only gas law that you actually get on the final exam. But it is significant in the fact that the combined gas law is more relevant to lab. In lab, especially this lab, it's very difficult to hold something constant. It would seem like temperature is pretty constant in this room, but the air conditioning is always coming on and off. The heat is always coming on and off in the winter. And so it's actually pretty difficult to hold temperature constant. You really need a much more controlled lab than what we have in here. So combined gas law, number 15. It wanted to know, why would you use the combined gas law? And you use it when nothing is constant. Okay? Nothing is constant. But here's the great thing about it. The reason they only give you this gas law on the state test is, suppose you were doing a Boyle's Law problem and it said temperature's constant. Well, all you have to do is look at the combined gas law. They're not going to ask you if it's Boyle's Law. They're just going to say temperature's constant. And if temperature's constant, that means you just take out the T's. You just remove the T's, which is harder to do on the smart board for this one, but you cover up the T's. And there you have Boyle's Law. P1 times V1 equals P2 times V2 from yesterday. And again, if it said volume was constant, you don't have to know that it's Gay-Lussac's law, but if it says volume's constant, you just take out the V's. And so your V's would disappear here, leaving you with P1 over T1 equals P2 over T2. So you can use the combined gas law to get any of the other three that we learned yesterday. So the state exam is pretty smart in the fact that they give you the combined gas law because it allows you to find the other three. Okay? Now we're going to show you how to do some combined gas law problems today. Number 16, we'll need a calculator definitely for number 16 today. And I will have you take a few seconds to read over number 16 as well. Remember, number 16 is on your outline. But I'm going to actually move to the smart board where you can see my work a little bit clearer, a little bit better. Okay. You'll notice the big difference in these problems compared to what you did yesterday and last night. These problems have 5 pieces of data in them. So instead of just giving you 3 pieces of data like yesterday's problems, today you have 1, 2, 3, 4, 5. 5 pieces of data. So that's how you know it's combined gas law. So here's my combined gas law formula in the red. Notice that again, I am looking for the new pressure of the gas, and they want that new pressure in millimeters of mercury. So that's another thing that's a little tricky about this problem. But it says if I have a gas at a pressure of 0.93, so I'm going to go ahead and use sentence 1 to get all of my initial conditions. Pressure 1, volume 1, temperature 1. My volume 1 is 50 milliliters. And my temperature 1, again, needs to be in Kelvin. And it's 25 Celsius. Again, that's room temperature. So that's 298 Kelvin. Okay? But it says the gas is cooled. So the temperature dropped down to 15 degrees Celsius. That's 10 degrees less So that's 288 Kelvin. And then my new volume is 35 milliliters. So I'm looking for pressure 2. Now some of you may have been very crafty and you said, okay, I'm going to go ahead and change my atmospheres to millimeters of mercury now. And that would be perfectly fine. If you don't mind, I'm going to wait and do it at the end. Okay, I'm going to wait and do it at the end. Now, you may be looking at this going, how do I solve this? And I always tell my students, this is just cross multiplication again. I can go from left to right because all my variables are in place. So mathematically, we're going to do 0.93 ATMs times 50 milliliters times 288 Kelvin. So I'm going to go from left to right. And then I'm going to divide by the things that are with the missing variable. And when I divide by two numbers, remember class from chapters 10 and 12, two numbers, when you divide by them, put them in parentheses. Put them in parentheses. So 298 Kelvin, 35 milliliters. Okay? And you can even see what units are going to cancel out when you cross multiply. The kelvins will go, and the milliliters will go, which is good, because I'm supposed to be finding pressure. Not necessarily ATMs, but I'm going to find pressure. So I'm going to go ahead and plug into my calculator 0.93 times 50 times 288. And then I'm going to divide by, in parentheses, 298 times 35. Okay? And so I get a pressure of 1.28 atmospheres, which is nice, but like I said, they want us to find the pressure in the millimeters of mercury. So again, look to your left to the long dry erase board and what we learned last Thursday. If you actually check that out, you'll see that we end up having a conversion factor here that we can use. Okay? So I've got 1.28 atmospheres, and I'm going to change that to the millimeters of mercury. So again, ask yourself, if I want to find millimeters of mercury, then the relationship between 1 ATM and millimeters of mercury is what? So 1 ATM equals 760 millimeters of mercury. And if I were there, I would ask you, why did the ATMs go in the bottom? And you would tell me because they need to cancel. Okay? So remember, your denominator has to match what you get. So, to get our final answer, we'll do 1.28 times 760. And that'll give us our final millimeters of mercury, which happens to be 972.8. Okay, 972.8. So that's your answer to number 16. So again, all you really have to do is cross multiply. Now this one is a little harder than, honestly, the ones you'll have on your classwork today. I have a second problem up here, and you don't have to write this down. I just want you to use your calculator. Okay? So, calculator, again, ready here with our P1 times V1 over T1 equals P2 times V2 over T2. And this one's a little simpler. So, notice in our first sentence, we have pressure 1, 2 ATMs. Okay? Volume 1 is 12 liters. Okay, and it tells me I have a gas contained at a pressure of 2 ATMs in a 12-liter container, and it's at 12 degrees Celsius. So 273 plus 12 gives me 285 Kelvin. And this time my gas gets heated. It goes up to 36 degrees Celsius for this one. So again, my 36 degrees Celsius is 309 Kelvin. And I want the new volume, so I'm looking for V2. And pressure 2, it tells me, raises to 2.4 atmospheres. So this time I'm looking for volume 2. And once again, I can cross multiply. You don't always have to go from left to right, but coincidentally that has been the case for these two problems. Left to right is complete, so I'm going to begin with that direction. 2 ATMs times 12 liters times 309 Kelvin. Okay? And I'm going to divide by 2.4 atmospheres and 285 Kelvin. Okay? And so your kelvins will cancel here, and so will your ATMs. And that'll leave you with a unit of volume, which happens to be liters. And this problem was not picky. They just wanted to know the volume. They didn't give us a specific unit. So in your calculator, you're going to do 2 times 12 times 309 divided by, in parentheses, 2.4 times 285. And remember, when you have 2 numbers in the denominator, use your parentheses. So this time I get 10.8 liters. Okay, 10.8 liters for this one. And so you notice the volume went down. And we might expect that because the pressure and the temperature both went up. So the volume usually is inversely related to pressure. It should go down. So 10.8 liters should be what you're getting in your calculator. So for today's classwork, again, you have the same sheet from yesterday. Boyle's Law, Charles' Law, Gay-Lussac's Law that you were working on yesterday. Now we want you to go to the back and try the back right, the combined gas law problems. Again, I want you to stay at your seats for this one and work with your neighbors there, but stay somewhere where you will concentrate on getting this done and working these problems. The nice thing about this right side, though, is that the pressures do match. But do remember to change those temperatures to Kelvin. We don't have anything really tricky about the pressure. Now, when you finish the back right, like Miss Couch is going to tell you here for this one, what I want you to do is to come up to the desk, the front desk here, and pick up this packet. It looks like it has Mount Everest on the top corner of it. And this is your test review. Don't panic. Your test is not tomorrow. In fact, it's not until next Wednesday, May 27th. So we've got a good bit of time here before you test. But I wanted to give this to you today because the front sheet's nice and you can fill in what you know on the front sheet, but the back sheet is what I want you to focus on. The back sheet, questions 1 through 9, give you further practice with Boyle's Law, Charles' Law, Gay-Lussac's Law, combined gas law. They give you more practice. Now, they don't tell you whether it's Charles' Law, Boyle's Law, etc. But what they will say in bold is temperature is constant. And think about it, if temperature is constant, remember that means you take out your T's. Take away the T's. Temperature is not changing, so you don't need the T's. Or if it said pressure is constant, like number 3 on this sheet, take out the P's, as in purple. Take out the P's here and remove those. And that gives you Charles' Law. You don't have to be able to name the laws, but you do have to be able to use them. So this is a page that you can work on, or you can work on your practice exam. When you get to this packet, your test review, and you finish with combined gas law, at that point you can go to the lab stations. Not right now, but when you finish combined gas law, you can go to the lab stations and work with others on either this or the practice exam that's due June 1st. You got that last Monday on May 11th. Okay? So those are some things to think about for the last bit of class today. And I look forward to seeing you tomorrow. I hope you have a good Tuesday afternoon. And again, be careful going home today. Thank you very much.